726 brings in a little new complexity. It gives us some different information. We have to do some calculating, but it says assume that the hourly cost to operate a commercial airplane, I'm doing 25, follows the normal distribution with a mean of $2,100 per hour and a standard deviation of 250. What's the operating cost for the least expensive of those airplanes? So we want to know, we know that we're going to be far to the left of the mean, right? Because we're down in that low part, just the 3%, right? Let's take a look at that visually maybe and see how we do that. So start here, and you know, I'm way down here, and I got to come up. I'm just in the decimal, so I'm looking for 3. I got a ways to go right there. Okay, 3. That's about as close as I'm going to get. And so my z score is minus 1.88. So let's put that there, and remember this formula. You know, we did this before, right? That our z is equal to our x minus our mean divided by our standard deviation. And so, you know, this is just to show you that we can work this a little bit backwards. And so I've put in the numbers, and I've said that my z is equal to minus 1.88. Okay, and that's equal to my x, which I don't know, minus my 2100 divided by my 250. Okay, so first we got to do this, right? And let's just say that this is equal to our 250 times our z. Okay, because algebraically, right, I can multiply both sides by 250. So I get a minus 470, and now I've got minus 470 is equal to x minus 2100, so I can add then that 2100, so it's equal to both sides, right? And that'll solve for x. So I add it to both sides, or I could, could have done that either way, right? I could also said it's equal to this plus my 2100. Okay, and I end up with $1,630. Again, does that kind of make sense? Well, if my mean is 2100 and I'm looking for the best 3 in terms of cost, least costly, yeah, you know, and my standard deviation's 250, sure. I'm a couple of standard deviations, almost a couple of standard deviations below that, yeah, that kind of makes sense. Okay, the other way to do it again is to use that normal inverse. And yes, I like to do both. Should have done the most recent, sorry. Normal inverse, okay. My probability is just 0.3. My mean, my standard deviation. Okay. And it came out to a, you know, a little longer number, but that's fine. Okay, 1,630.